Hello everyone, this is Dr. Srikanth Harle and we will be going through the design problem related to the connection. So we'll first of all write down the problem. So the problem is design a lap joint between two plates each of width 120 mm. If the thickness are 16 mm each, the joints has to transfer factored load of 240 kilonewton. The plates are of Fe410 grade. Use M20 grade of bolt and grade 4.6 of bearing type. So this is a problem. So we'll be going through the solution. So just look at the problem. Design a lap joint between two plates, each of width 120 mm. The thickness are 16 mm each. The joints has to transfer factor load of 240 kN. The plates are of Fe410 grade. Use M20 bolts of grade 4.6 bearing type. So before going through the solution, we just need to we'll draw two plates. That's one plate and then another plate. And that kind of connection is a lap joint connection. 16 mm thickness plate. So this is having 40 kN load. So we'll draw the stepwise step connection. Let us have the step number 1, given data. The diameter of bolt is given. That is equal to 20 mm. So we need to calculate diameter of bolt hole now. So check table number 19 of IS 800 2007 and table number 19, clearance of fastener hole, nominal size of fastener 16 to 22 mm, given standard clearance in diameter. Size of the hole is given, nominal diameter of the fastener plus clearance. So table number 19, page number 73, you are getting here 2 mm. Nominal diameter of the fastener plus clearance, that will give you size of the hole. So we can go with the diameter of bolt hole. So diameter of bolt hole we can get from the table number 19 of IS 800 2007. Right, there will be the different number of bolts if the problem is given. Then accordingly, you need to just go to the same table, and accordingly you can just check what kind of bolt nominal diameter is given and how we can get the bolt hole. And this is how you will get the bolt hole, diameter of the bolt hole. So that's 22 mm. So for different diameter, we can get the similar way. We can get the diameter of bolt hole. Most of the time, you need to just take the clearance. The different bolt will be provided. Now the ultimate strength of the plate can be given, which is already given in the problem. So denoted by Fu, and that is equal to 410 Newton per mm square. Once we got the ultimate strength of the plate, then we can go to the ultimate strength of the bolt. This ultimate strength of the bolt is denoted by FUB, and if it is not specified, then you can just take that ultimate strength of the bolt as 400 Newton per mm square. So this is how you can get the ultimate strength of the plate as well as bolt. Okay. The next part would be So clause 10.2.4.2 ISA 2007. So the minimum age and age distance from the center of any hole. From the center of any hole to the nearest edge of the plate shall not be less than 1.7 times the hole diameter in case of shear or hand clamp cartridges. Rolled or machine clamp cut on a plain edges, so 1.5 times the hole diameter. So from page number 74, this is how we will get. So the minimum edge distance we need to calculate. According to clause, it is 1.7 times the diameter of the hole. So we got this from clause 10.2.4.2, page number 74. So 1.7 into 22, which is the diameter of the hole, and we will get around 38 mm. And similarly, we can go with the minimum spacing criteria or the pitch criteria. Clause 10.2.2, IS 800/2007. The distance between the center of fastener shall not be less than 2.5 times the nominal diameter of the fastener. This is page number 73, clause 10.2.2. Earlier we have gone through the table number 19 to calculate the nominal size or the hole diameter, and just above that we have so now we will calculate in our case what is the pitch. So we will get the minimum pitch. Minimum edge distance can be denoted by E, while minimum pitch is denoted by P. Minimum pitch we have gone through, that is now 2.5 times the nominal diameter of the bolt. So clause number 10.2.2, page number 73, we got this, right? So here we've gone through what exactly the clause says, and therefore minimum pitch can be calculated accordingly. 2.5 times the nominal diameter of bolt. Okay, which is in our case 2.5 into 20, and that is equal to 50 mm. Okay, we can even recap now the design problem. We can recap. To design a lap joint between two plates, each of width 120 mm, and the thicknesses are 16 mm each. The joint has to transfer factored load of 240 kN. The plates are of Fe410 grade. Use M20 bolts of grade 4.6, that is bearing type. So accordingly, we can go to the solution of this plate connection. We have shown the plates, two plates, how they are connected with the lap joint. We need to put the given data, diameter of bolt, then we can calculate diameter of the bolt hole, and we can use the table number 19, page number 73 to calculate diameter of bolt hole. So you need to just check IS 2007 every time. Then ultimate strength of the plate is already given, and if it is not given, then we can take the ultimate strength of the bolt as 400 Newton per mm square. So page number 74, clause 2.4.2, we can get the minimum edge distance. And we can calculate the minimum edge distance accordingly. Once we calculate the minimum edge distance, then we can go ahead with the calculation of minimum pitch. And this minimum pitch we can get from the clause 10.2.2, page number 73, and 2.5 times nominal diameter of the bolt. And we got here 50 mm. So just take all the tables or the clauses accordingly. Different clauses you need to just take, understand what exactly IS 800-2007 means, understand properly, and the next time you can just ask if you have any kind of doubts related to it once you just go through it. Okay.